best strategy to be used is search for pattern. So find the next number in the sequence. We have A, B, C. So again, the first step is to understand the problem. Okay, so we really need to use the ability to recognize patterns is one of the most important skills in solving this problem. Okay, so shall we have the letter A? If you're going to find the next number, you need to consider the preceding and the succeeding sequence. Example, in order for you to get 9, think of a number that you're going to add, divide, or subtract, or even multiply to 5 to get 9. Since 4 is the closest number to add to 5 to make it 9, then do it to the next number. So 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17. Then you see that the pattern by adding 4 satisfy all the succeeding number. In short, if you're going to add 25 by 4, then you will have 29. So that is how you get the letter A. But on letter B, let us try to add, divide, times, or subtract a number to get the 6. If you're going to add 2 by 4, you will get 6. If you're going to multiply 2 by 3, you're going to get 6. Then let us go to the next number. If you're going to use the same pattern by adding it 4, so 4 plus 6 is 10. That will not satisfy the third sequence. But if we're going to multiply 6 by 3, then you will have 18. If you're going to multiply 18 by 3, then the product is 54. The same as if we're going to multiply 54 by 3, we have 162. So, if you're going to multiply 162 by 3, you have 486. And since the pattern shows satisfaction in the succeeding sequence, then we're going to multiply 486 by 3, so we will have 1458. So right now we're going to solve for the letter C. So since we have this as part of the given, then the requirement is the next number in the sequence. Second step is devise a plan. Think of a way to solve the problem. So again, let us have this. We know that the first term is 2, second is 8, 18, and the last is 72. So probably we are looking for the 7th term, 8th term, and so on. So but this time, let's just have the first 6 terms for us to know the succeeding terms. Okay, how would you know that the number that you're going to add, divide, subtract, or even to multiply will become 2? So here, you're going to multiply 2 by 1. What would be the number that you're going to add times to make it 8? Therefore, 4 times 2. What you're going to multiply to make as a product 18, and that is 9 times 2. So as you can see on the first 3 sequence, we just multiply the factor by 2. So in short, what you're going to multiply on the fourth term to make it 32. So we have 16 times 2. What you're going to multiply to 2 to make it as 50, 25 times 2. The same as in 6th term, which is 72, and that is 36 times 2. So as you can see, you see pattern here. By multiplying all equation by 2, whole factors by 2. The problem is, as the number goes by, there is an inconsistency in terms of the multiplicand. So that is now what we're going to look for a pattern. Okay, so the third step is about carry out the plan. Let us show it in this way. Okay, so we know that if we're going to multiply 2 by 4, we can have 8. That's it. The same as 2 times 9 equals 18, as well as 2 times 16 equals 32, and the last is 2 times 36. Let us observe to one of the factor. One factor is 2, the same, but the others are different as the number increases. However, that number are all perfect square. So in short, what we're going to do is we're going to expand it through exponential form. So right now we have 2 times 2 to the power of 2, 2 times 3 to the power of 2, 2 times 4 to the power of 2, and so on. And if we're going to have this kind of pattern, let us try to assume a variable or a symbol or a letter that will represent this this expanded factor, and this is what we call n square. So 2n square, where n is the nth term. So in short, in order for us to easily solve the next succeeding terms, so whatever terms this, as long as it follows this sequence, then we can able to solve it using this formula, 2 times n square. Okay, so here, think in this process, we were going to use the what we call the formula we able to have on the third step, and this is 49 times 2, since the square of 7 is 49 multiplied by 2 is 98. So again, just square the term and multiply the result by 2. In short, if we're going to get the 10th term of this sequence, so you're going to multiply 10 times 10, that is 100, then multiply by 2, that is 200. If we're going to go further in getting the the next sequence on the 20th term, simply you just multiply 20 itself, that is 400, then multiply by 2, that is 800. Okay, let us have the fourth problem. Okay, the best strategy to be used is working backward. Let us read together. Claire has a certain amount of money in her bank account on Friday morning. During the day, she wrote a check for 24.50 pesos, made an ATM withdrawal of 80 pesos, and deposited a check for 235 pesos. At the end of the day, she saw that her balance was 451.25 pesos. How much money did she have in the bank at the beginning of the day? So again, let us have the first step of George Bolia, the understanding the problem, and the keyword is C. So in this case, what we're going to do, or what we're going to apply as strategy, is what we call working backward. So meaning to say, we're going to do the end to start process. So we cannot have the right answer if we're going to start it at the beginning. In short, we're going to start the solution from the end to the beginning. Okay, so here we have the given 24.50 as the check, 80 pesos for the ATM withdrawal, and 235 pesos for the check deposit. So what is being asked in the problem? So we are asked to get the money she had in the bank at the beginning of the day. Okay, so the second step is devise a plan. Okay, in devising a plan, it's better to bring down all the necessary information in this way. So let's start with the end, which is the 451.25 pesos. Then there are some operation to be used here, and the operation to be used is opposite to the given action. Like for instance, start from 451.25 pesos because that is her balance. Then we're going to subtract it to 235 pesos because in the reality, she made a deposit. Okay, he made a check, which is to deposited a check rather for 235 pesos. But in working backward, instead of adding it, it will becomes subtracting it or deducting it. So that is the opposite work when we have the backward process. Now here, instead of in reality you're going to get the money from your bank, which is 80 pesos, in backward you're going to add it. So it's a total opposition to the given action when it comes to the operation to be used. Then lastly, when you wrote a check, you are supposed to get some money from your bank. So here you simply add it. These are the process for you to solve the certain amount of money she had at the beginning of the day or that morning, Friday morning. Okay, so this is the balance deposited, this is withdrawal, and this is check. Okay, so let us have now the third step, carry out the plan. The keyword is do. So simply just follow the sequence, bring down 451.25, subtract means minus, add means plus, and of course add it. So basically, if we try to simplify it using our own calculator or um, or using our notes for the manual computation, we will arrive at 320.75 pesos. So let us now look back, which is checking and interpreting your answer. So by simply knowing that the amount of money she had at the beginning of the day on Friday morning, she must have 320.75 pesos. So this times in the part of checking, we're going to do the process from the start until the end. So since 320.75 subtracted to 24.50 because she wrote a check, then you're going to another subtraction because she made an ATM withdrawal. Then right after that is addition because he put some money by depositing it, amount of 235. So since the balance at the end of that day is 451.25, then that really satisfy the given equation. So that is what the function of using working backward as the strategy in solving a worded problem. So again, I hope you have a clear understanding on what would be the right way or steps in using the working backward process. Okay, so this time, let us have the fifth problem, and that is about drawing pictures and diagrams as the strategy in solving it. So here we have two cars left at 8 o'clock a.m. from the same point, one traveling east at 50 miles per hour and other traveling south at 60 miles per hour. At what time will they be 300 miles apart? So again, read it more than once so that you can have a partial picture on how to solve this problem. So understand the problem. These are now the given. We know that there are two cars who left the same station at 8 o'clock a.m. with the speed of 50 miles per hour going to east, the first car, and as well as we have 60 miles per hour going to south as the car 2 speed. And they are in a certain time, there will be 300 miles apart. In short, the required is the time when they will be 300 miles apart. So in this case, we're able to really understand that we are trying to solve for the certain time which these two cars will be 300 miles apart, having a speed of 50 miles per hour going to east and 60 miles per hour going to south. So let us have the second step. Devise a plan. So better to draw it or make some diagram for us to give a clear visual on what we are really trying to solve. So here we have the first car going to east, second car is going to south. Okay, so here as we notice, their travels form a right triangle. And if it is a right triangle, obviously you can apply a theorem, and we call it as Pythagorean theorem. So in this case, we have x be the first car speed and y be the second car speed. So using this all, we can draw this kind of numbers. So since the first car going to east with the speed of 50 miles per hour, so we can write it in this way, 50 t or time. Then since the second is 60 miles per hour, then we can write it as 60 time. Okay, t is for the time. So we're going to use all the equation to solve for the value of the t or the time required for them to have 300 miles apart. Of course, with the use of Pythagorean theorem because it forms a right angle here. Okay, let us now carry out the plan. So still we have the Pythagorean theorem, we have the value of x and the value of y. Solution is, of course, bring down the Pythagorean theorem. Then before we're going to do the substitution, let us try to extract first or remove first the radical symbol by raising all equation to the power of 2. And it becomes 9,000 x squared plus y squared. So we're able to remove the radical symbol and squaring the 300, it becomes 9,000. So here, we're able to simplify it. Then right after that, we can now use the value of x and the value of y by substitution. So since we know that if we're going to multiply 50 itself and t itself, we have 2,500 t squared as well as 3,600 t squared. Retain equal 9,000. Then since t squared and t squared, they have the same variable as well as exponent, we can add them. We can simplify them. So it becomes 6,100 t squared. Then we are very concerned with the time required. So we're going to divide all equation first by numerical coefficient as 6,100. So what we have right now is like this. Then right after that, we can remove the 6,100 to t squared side. So we have t squared equals 900 over 6,100. Then we're going to remove the to the power of 2 by square root all the equation. Okay, so we have radicalizing the equation. So we have like this. We know that the final answer using our calculator is 3.84 hours or 3 hours and 51 minutes. So right now we're able to solve the given time. Okay, so how we able to say that the time required for them to have 300 miles apart? Simply, okay, you're going to add the result time to 8 o'clock a.m. That is 3 hours and 51 minutes. So you add them, the answer is 11:51 a.m. So at exactly 11:51 a.m., the two cars will be 300 miles apart. The problem here is, how did you get 51 minutes from 3.84 hours? So just follow this. We know in 1 hour there are 60 minutes. So simply the 0.84 that is in the hour form, you're going to multiply it by 60. And this is 50.4. Since zero point 0.4 is more than 50 minutes, so you're going to round it up as 51 because it's more than 50. So that is 51. That makes it as 11:51 a.m. Making lists and tables as part of our strategy to solve the sixth problem. Okay, let us read together. An algebra test consists of 10 multiple choice questions. 10 points are given for each correct answer, and 3 points are deducted for each incorrect answer. If Joshua did all questions and scored 22 points, how many correct answers did he have? So again, the best way to solve this problem is to use the step 1, which is the understanding the problem. Okay, the keyword is see. So if you're going to read it more than once, probably you're able to draw or picture out the possible solution. So right now, let us try to bring down all the different elements or important elements for us to know the possible solution. Okay, we have our given 10 questions answered. Score is equals 22, 10 points for each correct answer, 3 points deducted for each incorrect answers. So as you can see, you're going to answer all the items, which is 10 questions. And right after everything, the score that you must have is 22, considering that for every correct answer, that is 10 points, an incorrect answer will be deducted from that score, which is 3 points. So here, what is the required? Of course, the number of correct answers. Anyway, if we're able to know the number of correct answers, we can also solve the number of incorrect answers for us to have a score of 22. Okay, let us have devise a plan. So since it is making list and table as part of the strategy to solve this problem, so we're going to let the x be the number of correct answer and y be the number of incorrect answer. Okay, so the number of correct answer x plus number of incorrect answer y equals score. Okay, so here score equals to 10x plus negative 3y, or simply as score equals 10x minus 3y. How? Because for every correct, the corresponding score is 10. For every incorrect, the corresponding score is 3 points deducted for that point. Okay, so here, how to carry out the plan is, of course, we're going to use the table. So how can we formulate the numbers or the score in each table? So since the required is we're going to answer all the 10 items, assuming that in all items you're able to get all correctly. So 10 is the number of correct, 0 is the number of correct, so 10 times 10 is 100, minus 3 times 0 is 100. Okay, so that is 100 minus 0 is 100. So right now is, if you have make it 9 as correct, and of course 1 to make it 10, so 9 times 10 is 90, 1 times 3 is 3, then 90 minus 3 is 87. The same as here, 8 times 10 is 80, minus 2 times 3 is 6, that is 80 minus 6 is 74. Okay, so do the same process as you go down on the given rows. Okay, so for us not to be misled about the order of the numbers, let us try to do it in a descending order. So of course, right after the 7, it should be 6. If it is 7, it should be 3 would be the incorrect. So that it will equal to 10 items. Then if it is 6, you're going to add it by 4 to make it 10. So if in order for you to get the score, simply substitute all the values of x and y on the given equation. So 6 times 10, that is 60. 4 times 3, that is 12. 60 minus 12 is 48. The same as here, if we have 5 times 10, 50. 5 times 3, 15. 50 minus 15 is 35. And lastly, we have 4 times 10 is 40. 3 times 6 is 18. 40 minus 18 is 22. Then we're able to get the 22 points. That is how we able to have the right answer. In short, from the table you can see that Joshua, who scored 22 points, must have 4 correct answers and 6 incorrect ones. So Joshua had 4 correct answers. Okay, so look back, check, and interpret. For Joshua, x is equals to 4 and y equals to 6. So 4 plus 6 is 10 items, multiple choice. That's it. And therefore, if we're going to multiply 4 by 10, we have 40. If we're going to multiply 3 to 6, we have 18. Okay, then do the simplification. We have 22.